Hello, my name is Parker Webb, and this is my Lab 6 for Physics, the molasses magnet. The purpose of this lab is to learn and understand how the speed of a falling magnet changes as it passes through an aluminum tube. Some fundamental principles we need to understand are Faraday's law, Newton's second and third law, Ohm's law, and the magnetic force of a loop. This experiment is quite simple, as all it requires is a roll of aluminum foil and a strong magnet. First, you hold the aluminum upright with the hole facing towards the ceiling. Then, you drop the magnet through the roll and time how long it takes to fall. You repeat this 3 to 5 times for a more accurate data sampling. The data that we observed was that the length of the aluminum roll was 0.44 meters, and the width of the aluminum was 0.005 meters, with the inner radius of the tubing being 0.02 meters. The magnetism of our magnet being 3.2 am squared, and the mass of our magnet being 0.024 kilograms. After performing 3 to 5 drops, an average time for it to fall through the tube is about 1.4 seconds. For our code, we input all of our data that we just showed, as well as start our definitions for how to define the dipole magnetism of our magnet and aluminum foil. And by combining the force of gravity with our found force of magnetism, we can get a net force acting on the magnet, which, while it is still traveling downwards, the magnetism pushes the magnet up and slows it down as it falls. When discussing sources of error, we need to understand that we were not able to hold our aluminum foil perfectly straight up, nor were we capable of dropping the magnet straight down, which leads to it sliding around inside and causing a lot of friction, which could artificially increase the time it takes to fall through the foil. And if the resistivity of the foil was 0, then there would be more current and magnetism flowing through, which leads to the magnet slowing down further. On the other hand, if we were to poke holes into the roll of foil, then how the magnetism was oriented and permeating through the foil would change, as well as there being less foil overall, leading to lower magnetism and the magnet falling through at greater speeds.